In the previous video, I demonstrated how to fit a vise to the table of the machine and to align it using a dial test indicator. I also demonstrated how to fit the tool into the spindle, and in this next video I'm going to demonstrate how to begin making a V-block, which the drawing will be posted on this video. And the material that we're going to use to make this V-block from is mild steel. It's been sawn from a long length of bar, and the bar is 50mm by 50mm square. The finished length of the workpiece is 75mm. The bar has been sawn off at approximately 80mm long. The finished dimensions of the length of the height and width of the workpiece is 48mm, which means there's approximately 2mm to be removed from this dimension and this dimension, and approximately 5mm to be removed from that dimension. When you first get a piece of bar which has been cut off on the bandsaw, it will have burrs. It's very important when you're milling to have all burrs removed, as it can affect the accuracy of the finished workpiece. Any rectangular block has 12 edges and 8 corners which must be deburred. We also need to make sure that there are no bumps or dents on the faces of the 50mm dimensions. So after deburring the edges, the file should be placed flat on each of the faces and smoothed to make sure there are no bumps or dents on the faces. Once the piece has been deburred, it should be cleaned to make sure that no filings or swarf are left on the workpiece. This is very important for setting up with milling activity to make sure that accuracy can be maintained. The current width and height of the workpiece is 50mm. As I said before, the finished dimensions for the width and the height need to be 48mm. First thing you need to do is check the distance from the top of the vise to the bottom of the vise. This measures at approximately 53mm. If the workpiece is 50mm, it's obvious that when it's placed in the vise, the face of the workpiece is going to be below the top of the vise jaws. this is not any use. We need to have some method of raising the workpiece up so that the finished faces will be above the level of the top of the vice jaws. And for this purpose we use hardened and ground parallel bars. The parallel bars normally come in a set. They've been precision made so that they're perfectly parallel, perfectly smooth, and each pair is identical. The smallest set of parallel bars in this set is 14 millimeters in height, ranging in sizes up to the largest set, which are 50 millimeters in height. We need to calculate how much we need to raise the workpiece in order to get the finished face above the level of the vice jaws. If the height of the vice is 53 millimeters, we need to subtract the finished dimension of the workpiece, which is 48, which leaves us with 5 millimeters. That means that the height of the parallel bars needs to be more than 5 millimeters in order to have the workpiece raised to a suitable height. The smallest set of parallel bars that we have in this set are 14 millimeters height, so I'm going to use them. It's also very important, as well as deburring, to make sure that there's no debris or swarf in the bottom of the vice. The bottom face of the vice is critical in order to maintain parallelism when cuts are taken. The vice bottom and jaws should be cleaned thoroughly between each operation, because if swarf is underneath the workpiece and the workpiece is lying on swarf, it will not be level. Very important to make sure that the vice is clean. Firstly, place the parallels into the vice, one at the front and one at the back. Then place the workpiece into the vice so it's resting on the parallel bars. The vice can then be tightened, firstly by hand, and then by using a mallet, never a hammer. We have two different types of mallet here. One is a copper-faced and rawhide-faced mallet. Neither of these two materials will damage the vice. We also have what's known as a dead blow mallet. The mallet has a hollow body. Inside that body is an amount of lead shot. It can be heard moving from side to side when the mallet's shut. It has nylon plastic faces, and because it has the lead shot inside, when you hit something with it, the lead shot with its kinetic energy prevents a rebound, so it prevents the mallet from rebounding, which is good. On a milling vise, it's usual to tap the handle with a mallet a few times to ensure that the workpiece is tight. Tightening by hand is not normally enough to make it secure. However, you must make sure not to over-tighten the vise, or it will stress the screw which runs through the middle of the vise. Once you've tightened the vise, you should then use the mallet to tap the workpiece at the top. This will settle the workpiece down onto the parallel bars, and it can be checked to see if the parallel bars are tight underneath the vise, which they are.